Hi everybody, this is our bottle with hole demonstration, and that's exactly what it is. I have a 2-liter pop bottle right now filled up with water, and it doesn't show up real well, but I've got about a 1/4 inch hole, a little bigger, right here that I have a piece of tape over right now. And I'm gonna go ahead and take that tape off so that there's nothing going over the hole and something kind of interesting happens. And so I'm gonna go ahead, pull that tape off right now, and you saw a little bit of water spurt out that hole, but not a lot. It's pretty much staying in the container, and I want to take this paper clip now and I'm going to shove it right in the hole, and you can see that paper clip goes straight inside there, but none of that water is coming out. So the question becomes, why in the world can we have a hole in the bottom of this container where no water comes out? And this one's really tough because of our 3 ways to change air pressure, which is volume, temperature, or amount of particles. This one's really kind of hard to tell visually which one of those it is. Now, first of all, I think we can throw out temperature because I didn't change any temperatures at all, which leaves us mass and volume. Now, the air in this container is right up here at the top, and there was no way that I could add or take out air. That air right now is really kind of in a closed system. None can get in or out. But some of you may have noticed when I first pulled the tape off of our hole, some liquid, and here's our hole right here, it's hard to see, but some liquid did come out of the hole. And what that means is that that water line, you couldn't see it very well, but it actually imperceptibly dropped a little bit because some water came out down here, which means that airspace just got bigger. Not by much, but it doesn't take much. And we know from our first boxes thing that we did, when we have a closed system and we put the air in a bigger space, it becomes lower pressure. So we now have low pressure here, and the outside pressure is higher, and it wants at that low pressure, and it's pushing on all sides of this to get there, including that hole where the water's not pouring out, that again, I can poke this right on into. There's nothing obstructing that at all. So the thing that's holding the water in is the air pressure in the room is pushing against it right there and won't let it out. Now, if we make this a non-closed system and we give the air an easy way to get in there, which I'm going to do in a moment, then all of a sudden different stuff happens. So I'm going to go ahead and take the lid off. And when I take it off, you'll see what happens down below. And then I'm going to put my hand over the top of it. So I'm going to go ahead and take the lid off right now. And now you'll see that water shooting out. But if I put my hand over the top of it, it immediately stops again, because I now have a closed system again. That closed system just put this air in the top in a smaller space, lowered it. We now have high pressure outside. And all I got to do to make that pour or not pour is take my hand on and off the top of this. This is why cans that hold liquids need to be vented. They need to have a vent on top. Otherwise, they won't pour very well, because as the liquid comes out of them, the space inside gets bigger, the outside air pushes against them, and it doesn't want to let the fluid out. Now, gas cans, back when I was a kid, all had a little thing you would pop on the top. Modern gas cans, it's a little bit harder to see because the vent's actually built in the nozzle for the where the gas comes out. But you can see I can just control that flow by putting my hand on and off. But again, for your model, we have the low pressure in the top here. That low pressure was created by making the space bigger here as the water dropped. Our high pressure is outside the container, and our force is pushing right against that open hole, which is why the water won't come out. And that's bottle with hole. Thanks for watching.